Okay, for topic 8.2 or subtopic 8.2, let's start with this question. What is the direction of the force on the wire? Now, first thing we need to determine the direction of the magnetic field. Since we know that the magnetic field is from north to south, so we know that it's to the right, from left to right. So now using our right hand thumb with the current, index with the magnetic field, so we realize that the force will be out of the paper, out of the page. Okay, now here, in order to change the direction of the force, what should we do? Actually, if we increase or decrease any of the factors, that will not change the direction. Maybe it will change the strength of the force, but not the direction. To reverse the direction or to change the direction of the force, we need to reverse the direction of the current or the direction of the magnetic field, but not both. If we reverse both, we will go back to the original direction. So we can reverse the direction of the current or reverse the direction of the magnetic field. Part choice D. In choice D, they reverse both the current and magnetic field, and that will give us wrong answer. Next question. We have the wire, and this wire is passing through the magnetic field. We need to find the magnitude and the direction of the force. The magnitude F equal IL B sine theta. F equal, what is the current here? The current is 2, right? 2 amperes times L, which is 2.5, times magnetic field, which is 6 times 10 power negative 5, times sine theta. Of course, theta here is 90, which is the angle between the current I and the magnetic field. Actually, as you can see, the magnetic field is into the page, the current is to the right, so the angle between them is 90. Sine 90. Sine 90 is 1. So using the calculator, 2 multiplied by 2.5 multiplied by 6 times 10 power negative 5, the answer will be 3 times 10 power negative 4 Newton. And for the direction, use your right hand rule, thumb with the current, index with the magnetic field. So thumb to the right, index into the page, the force will be upward. So upward. Next question, we need to find the magnetic force. Also, we will use the same formula, F equal IL B sine theta. F equal, the current is 4.2, L is 7 centimeters, so multiply by 10 power negative 2. Okay, multiply by B, which is 4.25, sine 52, the angle. We will find that the answer is 0.98 Newton. So as you can see, the angle between B and the current is 52. So we use that angle. Okay. Now, next is a little bit different. Here we don't have current, we have moving charge. So what is the direction of the magnetic force? Thumb with the velocity, B with the index with B. So the velocity thumb to the right, uh, index downward. So the force will be into the page. But since it's negatively charged object, so we take the other the opposite direction. So we had into the page. Since it's negative, now it will be out of the page. Now, what is the magnitude of this charge? Actually, we know that F equal Q times V times B. Of course, it's times sine theta. But since theta here is 90 between the velocity and B, this is the velocity and this is B, the angle between them is 90. Sine 90 is 1, so we can ignore it. Now Q equal force over VB. Q equal, the force is 1.8 times 10 power negative 13 over V, the velocity is 7.4 times 10 power 5 multiplied by B, the magnetic field, which is 1.5. Using the calculator, Q equal 1.6 times 10 power negative 19 Coulomb. Okay, so by the way, yeah, this number rank, let's say, bring to my mind that this particle is either electron or proton, right? Because it has this charge اللي هي elementary charge اللي هي charge of electron if it's negative and charge of proton if it's positive. Okay, it's just an information I wanted to mention. I don't know why. Anyway, let's look at this question. We need to find the direction of the force, thumb with the velocity, index with the magnetic field into the page. So thumb to the right, index into the page. The middle finger will give us the direction of the force, which is upward in this case. And it's positive charge, so we will not change the direction of that force. Next question, please read it. Now, here we are talking about the force exerted on the particle. So this particle is moving actually in a magnetic field. Where is the magnetic field? The magnetic field is caused by the current in the wire. So there is current in a wire, this current in this wire causing or inducing a magnetic field. This magnetic field will affect the moving charge with a force. So what is the direction of B in this case? Using the right hand rule for the wire, thumb with the current, our fingers trying to catch the wire or roll around the wire. Above the wire, the magnetic field will be out of the page. So this is the magnetic field out of the page. Now we will use our right hand rule again to find the force in the particle. So thumb with the velocity to the right, index out of the page with the magnetic field. Now the direction is downward, but it's negatively charged object. So we will take the opposite direction. So the answer is upward. Yeah, that's it for 8.2. Inshallah, next video will be for 8.3.